Okay, here's problems 21 through 30 on the midterm. So, 21. Let's start with 20 again, just for a little bit of overlap, since they're kind of connected. 20 said to multiply x plus 2 times x minus 5. Okay, so remember how to do it. You use the FOIL method, and first, FOIL stands for first, outer, inner, last. Basically, we multiply each of those things by each of those things. That's all FOIL lets you do. There's no special order to do them. You just have to multiply each of these by each of these. So x times x is x squared. Negative 5 times x is a negative 5x. 2 times x is 2x. And finally, 2 times negative 5 is negative 10. So if you pull it all together, you're going to get x squared minus 3x minus 10. So then the question is, what if you have this one? Can you go backwards and get this? And you see how you would go backwards. You would need to find two numbers, negative 5 and 2, which multiply to negative 10 and which add to negative 3. See that? These two numbers add to negative 3 and they multiply to negative 10. That's how we went from here to here. So that's going to help us with the next problem, which is number 21. 21 says, solve this equation, x squared plus 2x is equal to 15. Okay, and I always tell my class, I think I probably said it on these series of videos as well, 0 is your friend. The reason 0 is your friend is because if you have a times b is equal to 3, a and b could be about anything in the world. They could be 3 over 17 and 17, for example. That multiplies to 3. Could be anything. But when you have two things multiplied which give you 0, then you know that one of those things has to be 0. So I'm going to take advantage of that fact and write this as x squared plus 2x minus 15 is equal to 0. Now, since 0 is my friend, I can just ask, just like I did here, what are two numbers which multiply to negative 15 and add to 2? And it doesn't take too long to think, oh, 5 and 3 are a couple things. I just have to get them in the right order. Plus 5 minus 3. See that? Because if you FOIL this out, you're going to get x squared. Here you're going to get 5x minus 3x is 2x, and then you're going to get minus 15. And so then, since this times this is equal to 0, you know that one of them has to be 0. Either one of them can. So that's one option. That's the other option. And if x plus 5 is 0, that tells you that x is negative 5. If x minus 3 is 0, that tells you that x has got to be 3. So there you go. So that's how you do one like that. Okay, how about 22? That one is pretty straightforward. Let's erase all this. And what does it say? Number 22 says 1 plus the quantity 3 minus 2x minus the quantity 1 minus x is equal to 4x minus 2 times the quantity x minus 3. Okay, so we just need to find the value of x that makes that true. It's pretty simple algebraically, but I doubt if very many people could do that in their head. So it just shows the value of having a pencil and the value of knowing the rules of algebra. So here, let's start by just getting rid of parentheses. 1 plus 3 minus 2x. Now I'm subtracting this whole quantity, so it's going to be minus 1. When you subtract the negative x, that's going to be plus x is equal to 4x. And here it's going to be negative 2x. And then negative 2 times negative 3 is plus 6. So you got that. Now I can combine all the x's on this side. I'm going to get a negative x, because there I have negative 2 of them and a positive 1. And here I have 4 minus 1 is plus 3. So I have 3 on this side. And on this side, I'm going to get 4x minus 2x is 2x plus 6. And now you could either bring the x's over here and have them all be negative, or you could bring this one over here and have them all be positive. I just as soon have things be positive in my life. So I'm going to add x to both sides, and I will subtract 6 from both sides. If I subtract 6, I get this. And then you divide both sides by 3, and you get x is equal to negative 1. Hopefully that's one of the answers. Yep, it looks like it's the second answer. So there you go. Okay, number 23. Another one where you just need to do some rather straightforward algebra manipulation. 23, we have x minus 6 divided by 3 plus 2x minus 1 over 5 is equal to 11. So, in the same sense that I don't like negatives in my life, I also don't like fractions in my life. So the way to get rid of all these fractions is to take this whole equation, both sides of the equation, and multiply it by 15. See that? Because the 15 will get rid of this one, will also get rid of this one, and it'll turn this into a bigger number, but at least I've gotten rid of fractions. So let's do it. So 15 times 1/3 is 5. So basically I can multiply the top of this thing by 5. Okay, 15 divided by 5 is 3, so basically I can multiply this thing by 3. And then finally I have 15 times 11, which I believe 15 and 15 is 165. Okay, there you go. Now we do basically what we did in the previous problem. We go get rid of parentheses. 5x minus 30 plus 6x minus 3 is equal to 165. And so 5x plus 6x is 11x. And if I take negative 30 minus 3, that's negative 33 is equal to 165. Then I can add 33 to both sides and get 11x is equal to, if I add 33 here, it's going to be 198. And finally, I have to divide both sides by 11. 198 divided by 11 goes in there once, 11. 88 goes in there 8 times, 18 times total. So there you go. That's all she wrote. Okay, let's do number 24. Twenty-four says, take 4/5 and take it to the 3rd power and write it as a fraction. Well, I happen to know that if you have something like that to the 3rd power, that means that everything in here that's being multiplied or divided, you do all those things to the 3rd power. So you just basically distribute that 3 all the way through. That's all there is to it. And then you just do what it says. 4 times 4 times 4 is 16 times 4, which is 64. 5 times 5 is 25, times another 25, times another 5 is 125. So 64 over 125. There you go. Okay, number 25. My goal is, by the end of our time together, I'm going to find a marker which works well. Okay. Number 25. It says match each graph to the core. Oh, look at here. This is 25, 26, 27. Should be 28. Whoops. We had an extra problem there. Look at there. You got an extra problem for nothing. 25, 26, 27, 28. So match each graph to the corresponding equation. Okay? Well, let's just talk about each one. I guess you just have to know them. This is the easiest one. That's just the straight line. Y equals, it could be y equals x. It's not really clear, but it's a straight line. So any straight line that goes to the origin is something of the form y equals mx plus b. If it had b here, then that would be the y-intercept, but with the b being 0, it just means it's a line that goes to the origin. It's got to be a positive number there. If we're a negative number, it would be going through like that. So y equals 2x is one possibility, so that must be it. Y equals 2x. Okay? The second one is a classic parabola. Okay? A parabola looks like that. Y equals x squared. As long as there's no addition to this, it stays right there at the origin. The only way you can really alter it is by putting a number out front. If you put a 2 out front, that makes it go a little steeper. So it might look more like this. If you put a 1/2 out front, it would look more like this. So y equals 2x squared is the obvious choice. This one right here is, again, once you know them, it's obvious. That's obviously an exponential. So it could be e to the x, or any number greater than 1 to the x power. 2 to the x works. So that's obviously 2 to the x. And that leaves the last one, which is a logarithm. So this is y is equal to the log, is it the log of x, and it should actually be log base something or another. Log base 2 or log base 10 or whatever, but any of those have the same form. So that takes care all the way through 28. Okay, now you're going to get 28 again here. Okay, 28 again. Given the following graph of a line, identify the matching equation. So in order to get the equation of a line, I need a couple points on that line. I notice the intercepts are 0, 5, and the other intercept is, it looks like 7.5. I'll say 15 halves. 15 halves. 0. So there's the x-intercept and the y-intercept. Okay, and as I say, I'll just keep trying. See if I can eventually get myself a marker that works. Okay, so let's see. How do we go about finding the equation? Here's the equation. Here's the method I like. I just know that if you have the point AB, and if the slope is m, then the equation of the line is y minus b is equal to m times x minus a. So, and then you can go from there. So, in our case, we need to first find the slope, and the way you get the slope is by taking, for example, 0 minus 5 divided by 15 halves minus 0. there was a little technical glitch there. So go ahead and simplify it. You're going to have negative 5 over 15 halves. Now I know that if you divide by a fraction, that's the same as multiplying by the reciprocal. So you're going to get negative 5 times 2/15. And that's the same as negative 10 over 15. And then you can divide out the 5 and get negative 2/3. So there's the slope. And then once you have the slope, you can get the equation of a line just by going y minus 5. Take any point on the line, we'll choose this one, is equal to negative 2/3 times x minus 0. And so we're going to get y minus 5 is equal to negative 2/3 x. And then you can add 5 to both sides and get the final result. So hopefully that's there. Negative 2/3 x plus 5. Yep, that's number C. Okay, very good. So that was number 28. Now we'll do number 29. Number 9, do the same sort of thing with a parabola. Given the following graph of a parabola, identify the equation. Okay, these are all good problems. Okay, here we have one that has the vertex at 5, looks like negative 9. So here you are at 5, negative 9, that's the vertex. And it goes through like this, goes through like that. Okay. So, that's not a very good looking parabola, is it? So, I know since the vertex is over here at 5, I know that the general equation is going to look something like this. It's going to be at x minus 5 squared. Okay? Because the x minus 5 squared, if I were just to graph that, that would graph into a one like this. X minus 5 squared would graph into that, because x squared, let me start afresh. X squared looks like this. When you go x minus 5, that basically says, okay, x squared has the vertex at 0. So now I ask the question, what do I have to stick in here so that I get a 0 squared? Okay? Let me just start that explanation again. If you start with x squared, it looks like this. If you take x minus 5 squared, that's going to look like this. The reason is that this has the vertex when this thing that's being squared is equal to 0. Same thing here. This is going to have the vertex when this thing here, which is being squared, is equal to 0. So what does x have to be in order to make that 0? X has to be 5. So there it is right there. So that's that. And now if you want to move it down 9 units, if you just subtract 9, that should do it. So that would be an example of a graph that would look like this. I don't know exactly where the y-intercept is, but let's see once if that's the only one that looks like that. I have an x minus 5 squared, e, and then minus 9. So that's the only one that looks like that, so it's got to be e. Okay, it's got to be e. So that's 29. Okay, 30. 30, we do the same sort of thing with exponential functions. Okay? Here's the most basic one right here. There's an exponential function that there's an exponential function that could be of the form e to the x, or it could be of the form 2 to the x. They all have the same general shape, and what's key is that they all go through the point 0, 1. Okay, all those 2 to the 0 is equal to 1, e to the 0 is equal to 1, 10 to the 0 is equal to 1. They're all equal to 1. So anything with a number that's greater than 1 is going to have something which increases as you go from left to right. If I had 1/2 to the x, that would be a graph that would look like this. Go down. So I want some number which is greater than 1. So right away, I see that a and b are possibilities. C and D are not possibilities because those are numbers less than 1, so they're going to go down like this. E and F are not possibilities because if you take the negative of 2 to the x, it's going to be the same thing going down here. So that's no good. So things with negatives in front of them are no good. And so the two that look promising are A or B. And then I say, aha, look at the one we've got, the one we have. The intercept is not at 1, but at 4. Which means I want to take one of these graphs, which are all possible. This one would be possible. This one would be possible. This one would be possible. But I want it to go not through 1. I want it to go through the value 4 when x is equal to 0. So by taking all those things and multiplying them by 4, that's going to raise it so that it goes through the point 0, 4 instead. So the only one that looks like that is going to be number A. A does the job. Okay? So, that was a good one. Okay, so that was through 30, and I guess that kind of comes to the end of a little section. So let's stop right there, and then the next video we'll have 31 through 40. So we'll stop right there.